In today's lesson, we'll discuss drawing tangent lines to curves. And perhaps you know that the slope of a line tangent to a curve is the same as the derivative of the function that produced that curve. But it's the derivative at the point of tangency on the function. So let's talk about that in a little more detail. So this is the same function, sorry, it's scaled a little bit differently. If I would like to draw a line tangent to this function at a given point, here we're going to look at that point right there, then the slope of the line tangent to the curve at this point is the same as the value of the derivative of the function that made that curve with the derivative evaluated at that particular point. So the graph just grew a little bit. If you look at this graph, what you'll see is now the red function that I drew is the original curve. The purple dot is located at x comma, it's actually located at 1 comma f of 1. In general, our points will be located at x comma f of x. And here, I'm locating that point at 1 for the x-coordinate, and the y-coordinate is the y value of the function. Then, you'll see the green line is the tangent line. We'll draw lots of different tangent lines for you to see, but this tangent line right here is the line that just scoots along the red function at a particular point. And what that means is we're looking at coming right around, right around this area of the function is where we want the line to be tangent. So now we have the function and we're looking at a different point. At this time we're looking at drawing a line that's tangent to the red function at the point -5 comma f of -5. It turns out for it to be kind of tricky to draw these tangent lines by hand. It might show the process better, but I found that I'm not real good at drawing them on this screen. So what you ought to see now is right here is the tangent line that I drew, and it's tangent to the red function, and again the point of tangency is right there at the x-coordinate of -5. What I hope you notice about the point of tangency and drawing to the function in general is that we want to draw on the convex side of the function. That's on the part that would be sort of on the outside, on the part that wouldn't be holding water if one side of the function would be holding water. I also want you to notice that we're kind of making a teeter-totter or a seesaw where we've got this point and we want to balance the line that we drew so that it would balance gently on that point. If you see these two little gray dots, you'll realize that the tangent line goes through these dots, and we're trying to make a line that just hits the function at that point and just hits the function at the point where x is equal to -5 and slides away. You can think about it as it's just kissing the function goodbye. So I took us back to a clean copy of that graph, and if we want to estimate f prime at -5, or the derivative of the red function at x equals -5, and we can't do any calculus, we're just going to draw a tangent line and approximate the slope of the tangent line. Well, to do that, we'll say it's approximately equal to, that's an equal sign with a little dot living above it. then what we'll do is we'll find 2 points on the function. So we'll have the coordinates of this point right here, and those coordinates are approximately, let's see, -7, 0. Any 2 points on the function ought to work. And we can have another point, and let's take this guy right here, which looks like it has coordinates of -4 and -4.5. So to approximate our derivative, we're going to find the slope. So change in y, which will be 0 minus -4.5 over the change in x, so -7 minus -4. And before you do any arithmetic, think about whether this derivative ought to be positive, negative, or 0. And when we do our calculations, you'll find out that the value for our slope is, -1.5. That means that we think the derivative of f of x at x equals -5 is equal to -1.5. Now, everybody who's taught calculus knows that drawing tangent lines gets easier the more you do it. It just takes a lot of practice, and be willing to make mistakes and revise your work. Thanks. See you tomorrow.